Okay, when I say the word robot, what's the first thing that pops into your head? Probably something made of metal, right? Lots of gears, kind of rigid, maybe a little clunky. And for decades, yeah, that's pretty much been the standard. But what if that entire idea is about to be completely flipped on its head? Let's dive into that, because this shift isn't science fiction, it's happening right now.
So on one hand, you've got your classic robot. It's rigid, it does one pre-programmed thing over and over, and you usually keep it behind a cage for safety. But then you look at the other side and it's a totally different ballgame, right? We're talking about robots that are flexible, that can work with us, and that can adapt to new situations almost like a living thing. The difference is just wow. And it all boils down to one revolutionary idea.
And that is the big question for today's explainer. I know, it sounds kind of weird, doesn't it? A soft machine. But trust me, this one simple question is cracking open a future that looks a whole lot less like a factory and a whole lot more like something you'd find in nature.
All right, so let's get into it. We are officially leaving the age of clanking metal behind and stepping into a completely new era. This is all about a field called soft robotics, and it's not just tweaking the old rules, it's pretty much tossing the entire rulebook right out the window.
So what exactly is it? Well, soft robotics is all about building robots from flexible, squishy materials. Think silicones and rubbers instead of steel and aluminum. And this is key. We're not just talking about putting a foam glove on a metal hand. No. We are talking about machines that are soft all the way through, from their core right to their skin.
Okay, but why? I mean, what's the point of a squishy robot? This is where it gets really, really cool. The advantages are huge. For one, they're way safer to have around people. They can squeeze into tiny cracks in a disaster zone where a normal robot just couldn't fit. They can pick up something super delicate, like a strawberry, without smashing it. And get this, they could even be used inside the human body for surgery. The potential here is absolutely transformative.
So you have to wonder, where did this crazy idea even come from? Well, it turns out the best engineer for this kind of thing has been perfecting these designs for, just a few billion years. The ultimate blueprint isn't in a lab. It's all around us. It's nature.
The guiding principle here is something called biomimicry. It's a pretty simple idea, really. You just look at how living things work and, well, you copy them. I mean, think about it. Animals are almost entirely made of soft stuff, and they move through the world with this amazing grace that our best engineers can only dream of. It's like nature did all the hard research and development for us, you know? We just have to be smart enough to pay attention.
And here is the perfect example. The octopus. This animal is incredible. It has 0 bones, which means it can literally pour its body through the tiniest little cracks and handle things with a dexterity that's just mind-boggling. It's basically the poster child for what you'd want in an adaptable, versatile soft robot.
But it's not just animals, which is what I find so cool. We're getting inspiration from plants, too. Seriously, just think about a pine cone. It opens and closes all on its own based on how humid it is, or how a plant uses water pressure inside its stem to move and change shape. It's this super simple, super elegant piece of engineering, and it's happening in backyards all over the world.
Okay, one more for you, and this one's wild. The spider. You might think they just use little muscles to scuttle around, but nope. They actually use compressed fluid, their blood, which is called hemolymph, to get that incredibly precise and powerful control over their leg joints. So yeah, next time you see a spider, you're not just looking at a bug, you're looking at a tiny master of microhydraulics.
Okay, so the inspiration from nature is amazing. We've got the blueprint, but that leads to the next big question. How in the world do you build something like this? How do you make a machine that's as squishy and flexible as an animal? Because let's be real, your standard factory tools are just not going to cut it.
Well, a huge part of the answer lies in advanced manufacturing, especially 3D printing. Researchers use these cool techniques like direct ink writing. You can basically picture it like a super precise robot arm squeezing out silicone ink, kind of like a fancy cake decorator. This lets them print complex channels and structures right inside the robot's body. The end result? You get a single, seamless robot with no weak spots from glue or separate parts. It's all one integrated piece.
Right, so you've printed the body, but now you gotta make it move. There are a few really clever ways to do that. You can use an electric field to basically zap a special material and make it change shape almost instantly. Then there's the thermal approach, using what are called shape memory polymers that can remember a shape and pop back to it when you heat them up. Or you can use pressure, pumping air into tiny channels to make them contract and expand, kind of like real muscles.
And this
This is where it all pays off. You take the inspiration from nature, you combine it with that high-tech manufacturing, you add in these clever ways to make them move, and what you get are some applications that are seriously straight out of science fiction.
I mean, just check this out. We're talking about surgical robots that could navigate through the body with minimal damage. We're talking soft exosuits that help patients in rehab without clunky metal frames. In factories, you could have robots working right next to people, totally safely. And then there's exploration. We could build robots that mimic sea creatures to explore our oceans, or maybe even explore the mysterious oceans we think are on moons like Jupiter's Europa. Just imagine that, a robotic squid swimming in an alien sea. Incredible.
And if you're thinking, sure, but they must be fragile, think again. Get this. Scientists built a self-powered soft robot inspired by a deep-sea snailfish and sent it to the deepest point on Earth, the Mariana Trench. We're talking pressure that would instantly crush a military submarine. And this little soft robot? It's a swim around, no problem. That's the power of going soft.
So yeah, the potential is clearly enormous, but we're not quite living in that future just yet. So what does the road ahead look like? What are the challenges we still need to overcome, and how might all this technology really change our lives?
Okay, so let's be real for a second. It's not perfect yet. The biggest strength of these robots, their amazing flexibility, is also a challenge. You know, like an old rubber band, the materials can suffer from fatigue after flexing over and over again, and they can get brittle in super cold environments, which is a big deal if you want to send one to space. These are the big engineering puzzles that teams around the world are working to solve as we speak.
But you know, the idea of a soft, helpful robot has already captured our imagination. If you've ever seen Disney's Big Hero 6, you know Baymax, that big inflatable healthcare robot. Well, he wasn't just some fantasy. His design was directly inspired by real-world soft robotics research that was happening at Carnegie Mellon University. So Art was imitating some really cool science.
And that really brings us to our final thought. We started this whole journey with the image of a rigid industrial machine. We've ended with something inspired by nature, built to be safe and flexible and collaborative. So as these robots get softer and friendlier and maybe a little more lifelike, it forces us to ask a really big question. How will our fundamental relationship with machines change? It's a soft future, and it feels like it's just beginning.